infrastructure and application choice with Docker Enterprise. First off, I kind of want to start as a little bit of a recap on where we came off in the last episode. And just to make sure that everyone's understood and what we're talking about here when we talk about an application container. An application container is your application code and the binaries and libraries required to run your application all bundled up into an artifact. That artifact does not contain the host operating system. It does not contain a kernel. It does not contain a networking stack. All of those components are shared from the underlying host, but an application container is just your application code and the binaries and libraries required to run that application. So for example, it could be your web server as the application code, sorry, your web content as the application code, and then the binaries and libraries could be, I don't know, IIS from Microsoft with a .NET framework underneath. Or it could be your Java application code with the binaries and libraries being your JVM. That is what we're packaging up. That is what an application container does. And one of the key things and one of the key themes throughout this webinar as we go forward is once we package up your application as a container, you now achieve portability. One of the key, I guess, visions or kind of goals or North Stars for Docker as itself is any application, any operating system running on any infrastructure. Whether you're packaging up traditional applications, microservices applications, packaging up software from ISVs, doing big data workloads, blockchain workloads, or even going all out to serverless, all of those things can start to run in containers and can start to run on the Docker platform. Whether you're a developer developing applications locally as part of your development lifecycle, you want to package them up into containers, or whether you're an operator who just wants to streamline his operations, automate more of his application provisioning, they can all take advantage of containers. The Docker platform then is the layer that will separate your applications from their infrastructure. That provides us the portability that we'll talk through as we go through this webinar. And today the Docker platform can run in the cloud, public or private, can run as virtual machines in your data centers, can run on physical servers as bare metal. And we're also starting to see more and more use cases of the Docker platform starting to be used on edge and IoT devices as well. Once applications are packaged up as container images, they really can be deployed and run anywhere the Docker platform can run. Last time in the last episode, we introduced the 3 core pillars of Docker's platform: choice, agility, and security. Today, we're going into that choice pillar. That is what we're going into today, and we'll spend around the next 40 minutes or 35 minutes now looking into the choice that the Docker Enterprise Container Platform brings when starting to containerize your applications and deploy your containerized workloads. We will look at agility and security further on in the series. So the 3 core pillars of Docker Enterprise, what's behind the titles? So let's look at choice. And this comes out with any application can be containerized. We don't want to have an opinionated view that says you can containerize any application as long as it's framework X, or you can containerize any application as long as it's been developed in the past 12 months. That's not the ethos of Docker. We're really helping you containerize new applications, cloud service applications, microservice applications, as well as traditional enterprise applications. We're seeing a huge interest in people working with Docker, taking their existing applications today, containerizing them, and then getting the benefits of portability, agility, and infrastructure savings. So as part of the Docker Enterprise Platform, we provide that choice. We provide the choice of what applications you can containerize. We also provide the choice on the infrastructure side. Whether you're working on-premise, off-premise, in the cloud, or on the edge, we really don't want to lock you down and say, well, you can run containers, but you can only run containers on this one operating system. Or you can run containers, but you can only run containers on this one piece of hardware. That's not us, and that's not one of the ethoses of Docker Enterprise, and we'll talk a bit more about that today. We're also working hard to avoid lock-in, whether that's through standardizing things like the container image format, standardizing the distribution of container images, or standardizing the actual runtime for containers. We're really working hard to kind of provide confidence that once your applications become containerized, we're not forcing you down a certain path. So in the last episode, we looked at some of the common use cases of Docker Enterprise, everything from modernizing traditional applications to modernizing your software supply chain. And in this particular episode, we're going to look quite closely at these two. How Docker Enterprise enables you or complements your cloud strategy, as it helps you migrate applications to the cloud. And it also helps you avoid lock-in once you get to the cloud. We all know today that each cloud vendor is working hard with cloud native services to keep you on their platform. One of the great things around containers is it provides that agnostic layer. So once an application is containerized, it really can move between different environments and different clouds. So we'll talk a bit more about that today. And we'll also look at how we can help you reduce data center expenses. There's a key business case and a strong TCO when you start to look at containers and you start to look at containers in the Docker Enterprise platform. When we start to go from the model of having one application deployed per server, and then we move to the container world of having more than one application deployed per server, we can start to reduce our virtual machine footprint, we can start to reduce our operating system license spend, and really can start to drive up the utilization of our assets. So we'll look at that today as well as part of choice. So today, the Docker ecosystem, it really is one platform, one tool set for all environments. And hopefully you'll see this when we start to go through some of the demonstrations. But you can run Docker today natively on your laptops. You can containerize your applications natively on a Windows or a Mac, and we can even run Docker on a Linux laptop as well. So you can really containerize applications locally. Once applications are containerized, we can then start to run on Linux machines, and Linux containers have been around there now for quite a while. We can run on Windows machines. We have Windows containers, and we've been working with Windows containers in Microsoft now since 2016. We've done a bit of work on running containers on mainframe. I will caveat and say that's Linux on mainframe, but we absolutely can start to run mission critical workloads on sort of IBM Z and IBM P series as containers and on top of the Linux operating system. And then we really do have deep integrations and deep ties with all of the major public cloud providers. I've only put 3 on the slide here, but I know that you can run containers in a lot more than that. And the idea here is that once the application is containerized, it can maybe be containerized on the laptop, you can then move between the platforms at ease. We're not locking you down into, well, containers will only work on Linux, or containers will only work on Linux on Amazon, or anything like that. The idea here is that Docker provides that agnostic layer between your applications and its infrastructure, so you can migrate between all. And absolutely, we believe containers can enable a hybrid cloud model. Seamlessly move between on and off premise. This could, as we've talked about, a container image contains everything your application requires to run. So it's your application code and the binaries and libraries required. Therefore, there'll be no dependencies really on the infrastructure for your application. We need a modern OS and we need a modern kernel, but in terms of the prerequisites for the application, they should all be bundled up inside of the container image. So therefore, if you wanted to move that application container from private cloud to public cloud, for example, everything required to start that application, to run that application, should be living inside of the container image. Therefore, you're not having to ship around all these different pre-compiled artifacts depending on environments. You're not having to create runbooks that are environment specific or anything like that. Once you containerize that application, it is then agnostic of the underlying infrastructure. You can even go to the point, and we'll show it in a demonstration shortly, where you can containerize that application locally, and a developer containerize an application locally on his desktop, migrate the application to one cloud, work with it there. If he wants to roll that out, he can move it then to a second cloud. Completely agnostic to the infrastructure, completely agnostic to any of the cloud provider APIs or anything like that. We are truly avoiding lock-in with containers. Back to a previous point that I mentioned, that we don't need to now start to write runbooks that are environment specific. Application definition can be written in clear text. It can be written in common frameworks and common languages, such as Docker Compose. And these describe how your container will run. And we'll jump into that in a bit more detail, but then you start to have a container image which has all your application and binary code, and then you have one clear text file which defines how your application starts. And that's the only thing you need now to move your applications between environments: the application code and its definition file. So what is application definition? Here I'm going to talk a lot about Docker Compose. Docker Compose is a standard or an open source project that we've been working on now for a number of years here at Docker. And Docker Compose is basically a clear text YAML file that can live alongside your applications in source control. So it's a single file. You store it inside of your next to your application binaries. It lives in source control, so therefore it goes into full release management. And inside of it, you just define out all of your applications. And what I mean by that is, an application is often made up of multiple containerized services. For example, on the left-hand side here, you can see that there is a service that is a database, and you can see that there's a second service that is a web tier. Now, in one definition file, I have clearly listed out that my application is made up of two services, a database and a web tier, and then I can start to define some runtime characteristics. When an application starts, use this particular container image. When the application starts, expose it or open up a hole in the virtual firewall on port 8000. Or whatever it may be. And so, as well as packaging up my application as a container image, I can write a really simple definition of how the container images will interact, how the services will interact. And once again, this is all now infrastructure agnostic. That one Docker Compose file will tell me how to deploy my application, no matter which environment it's running on. It's not saying, if on Amazon, use this API, if on Azure, use that API. Because Docker has abstracted us away, that one Compose file will deploy your application no matter what infrastructure it's sat on. Once you've written your application definition files, you can then just use one command, one line to start all of your dependencies. Something like Docker Compose up will bring up the full application. So let's jump into a demo, and hopefully that we can start to see this in action. So I'm just going to jump quickly to a terminal session, and then we'll jump into Docker Enterprise. So We'll start here with one of the famous demo application that we looked at in the last episode, and that was a website I've developed to show GIFs of cats. Pretty simple, pretty straightforward. Inside of my current directory, you will see that I have my application code. So you can see that I've got a Go binary and I've got some files. And then I have two very critical files. I have a Docker file, which defines, as we talked about last time, how to build a container image. And we have a Docker Compose file, which talks about how to run my application, no matter what infrastructure it's running in. So the first thing I will do to kind of prove full, I guess, mobility, I'm going to run the application locally. For this, I'm going to use Docker Desktop Enterprise. So Docker Desktop Enterprise is a product that enables you to run containers locally on your local machine. So I'm just running here a Windows 10 machine. I want to start to containerize some Linux applications. Docker Desktop Enterprise provides me an environment to work with Linux containers or Windows containers locally on my machine. So first thing I'm going to do is I'm going to containerize my application. Pretty simple. Docker build, give it a name, webinar demo, and off it goes. Great. So what I've just done now is I've turned my my application as it is into a container image. I can run my application locally pretty easily. So Docker container run, run it in detached mode, and open up a virtual firewall port so I can have a quick look inside, but webinar demo. Great, so I now have my application running locally. A quick jump in a web browser to localhost on 8080. There we go, I now have the famous web server. Great, so containerize an application. It is now infrastructure agnostic. It is now ready to be moved to the cloud. I don't want to have to ship around that command. That Docker container run command, there's variables in there. I don't want people having to remember that. That needs to now start to live in a text file. That needs to come live in source control. And we do that through Docker Compose. So if I now have a look at the Docker Compose file, you can see I have two components to my application, or I will have two components. I will have the web tier that you just demonstrated, and I'll have a database for us to store some of the content. Now, in a compose file, I've clearly listed out the two applications. I've also then listed out some things about those applications. So this is the port that it was required to run. I don't have to write that down in a runbook. I don't have to write that down in kind of any installation instructions. It lives alongside your application in source control. I've even listed out things to say how many replicas to run and things like that. So if I was to take the containerized application you just saw me containerize, and I'm going to push it up to a container registry. Now, a container registry is how we distribute images. It's the kind of the artifact store in the middle. So I'll just take my container image called webinar demo and rename it. Just going to rename it to my registry. And now I want to push it. So what I've just done is I've taken an application that I have locally. I've containerized it. I've run it to say it works, it's great. And now I've pushed it up so it can be ran anywhere. A quick look inside of our container registry should show us that we have a cat demo image pushed 20 seconds ago. Excellent, good. I now have the container image off my development machine into my artifact store, ready to go through a level of delivery process. Then the question will be, well, how do I tell my environment in Amazon, or how do I tell my environment in AWS, in Azure, or how do I tell my environment in VMware how to run this application? I have the application containerized, but how do I tell them how to run it? And the answer was simple. It was that Docker Compose file. So if we take that Docker Compose file in its content as it is and copy it across, I can now drop this inside of any Docker enterprise environment, and it will start up the application. So go to a new stack, create the stack, webinar demo. I want it to be on Swarm. I want to use compose files, and there we go. It's that simple for me to take an application, define it, and then run it. Now I can take that same compose file and put it into any Docker enterprise, and it will start up this application. Ooh, there we go. Created successfully, done. So I now have 2 services running for my application. It's exposed publicly. So if I go to a web port now on the internet, so a completely different URL, there we go. I can get to my application. So containerized it locally, wrote a compose file to say how to start it, and then moved it from my laptop to a cloud, or moved it from one cloud to a second cloud, or moved it from on-premise to the cloud. Like there is nothing that I had to do on my Amazon infrastructure there to tell it how to run the application, in terms of I didn't have to SSH onto a machine. I didn't have to install any binaries. I didn't have to say web server coming in, install Nginx or anything like that. It was all hosted inside of that container image. Okay. So kind of moving through and along. So a Docker enterprise we talked about is absolutely platform and infrastructure agnostic. We work absolutely fine on-premise, off-premise. We support all of the major public clouds, as well as all the major private clouds and on-premise solutions. But at the same time, we are multi-operating system and multi-Linux support as well. We provide choice at every layer. And what I mean by that is you can build out this stack on any Linux distribution that you'd like. We don't want to sit there and say you have to use, I don't know, an enterprise Linux distribution. You can use an open source variant. You can use an enterprise variant. You can absolutely mix and match to say what you want to build on. At the same time, if you wanted to run Linux containers and Windows containers, absolutely fine. We've supported Windows containers now since 2016, and we can absolutely run Linux and Windows in the same environment, in the same cluster, in any cloud. It really does provide you with choice. We even have support today for hybrid environments and hybrid clusters. Let's say you're working on an application that has, I don't know, a Java or a Tomcat front end running on Linux, and you have a SQL Server backend containerized running on Windows. You want to containerize both components. You want to put both components inside of container images, and you want to define the application as a compose file. Even though they are completely different operating systems, this can be done today, ran on the same environment, and ran today on Docker Enterprise. Maybe you're in a situation where you're starting to migrate parts of your microservices across from one operating system to another. Maybe today you have a Windows application, a microservice Windows application that you're starting to migrate components across the .NET Core. And you could do something like every time you migrated a component across the .NET Core, the rest of the application is still running on Windows, And you can now have a completely mixed environment where you have new components in .NET Core on Linux and old components on .NET Framework on Windows. You absolutely can start to run mix and matched environments. As part of Docker Enterprise, we deploy overlay networks for containers to communicate. And we can actually create overlay networks that bridge Linux and Windows containers. So when those Linux and Windows containers communicate with each other, they'll actually run across that overlay network, agnostic of the underlay. So therefore, all of the kind of networking complexity of multi-operating system, multi-platform gets taken away. It's all kind of agnostic or abstracted away from you, a bit like an application container is. And Docker Enterprise today is the only platform that supports Windows containers in production, and it's the only platform that supports Windows and Linux containers in the same cluster. So one of the other common questions and one of the other great things about choice that we provide as part of Docker Enterprise is we honestly don't mind which container orchestrator you use. If today you have an application team developing an application in Docker Swarm, and you have a second application team developing an application in Kubernetes, we honestly don't mind which orchestrator you run across our cluster. Docker Enterprise supports them both. As part of Docker Enterprise, you get a fully supported Swarm and fully supported Kubernetes distribution. Both orchestrators are deployed at installation time. Both of them are managed via our management tools. And so then the question becomes, as an application team is developing an application, it's their choice, depending on the feature set of the container orchestrator, which one they use. Let's say they are doing an awful lot of work on Windows and Windows containers, then Swarm may be the orchestrator of choice for that application team, because today Docker Swarm has had quite mature and production level support for Windows containers for a number of years. Whereas, let's say the second application team is doing an awful lot of work with, I don't know, single run containers, basically cron jobs in containers, and that may be driving them or steering them towards Kubernetes. Absolutely, then fine, no problem. We will have both orchestrators running inside of our environment. And it is absolutely up to the application team which one they use. Docker is also working on ways to start to abstract away the orchestrator from the application team. And we're doing this through application definition. We talked before about how a Docker compose file can be used to define how an application can run, and that the same Docker compose file defines how an application can run on any environment. Well, today, we've actually done an awful lot of work to make Docker compose agnostic of the orchestrator as well. So you write your application definition once, and then all applications, whether they are Windows or Linux, Kubernetes and Swarm, can be defined the same way using the same clear text YAML, can all live in source control. And then as part of Docker Enterprise, we can choose whether that application is going to run on Swarm or it's going to run on Kubernetes. We're not locking you in any way. We're not kind of forcing you down one path. If you wanted to start out, an application team wanted to start out on Kubernetes and then migrate to Swarm in a future release, or vice versa, they don't have to change how they can package their applications. They don't have to change how they define their applications. Docker Compose abstracts both away from you. All of this technology here is open source. This was a big announcement for us at our last DockerCon in December, that you can run Docker Compose today on top of any Kubernetes environment. There's a link in the slides here to find out more about it, and if you wanted to start to run Docker Compose across your other Kubernetes environments, you absolutely can do. And it's all really here to provide choice, as in write your application once and kind of abstract yourself away from the orchestrator, from the operating system, and from the platform. Okay, so let's have a look at some demonstrations of this. Jump back to my command line, and we'll go to demo 2. So in here, I have a pretty simple Docker Compose file. This Docker Compose file is made up of free services in one application. It's made up of a database tier, it's made up of an API tier, and it's made up of a web tier. 3 container images that I've already pre-packaged and I've already stored on my registry. Inside of here, you can see some things around the number of instances of the API server I want to run, and things about, well, what port in the firewall do I want to open up? That's my application definition, and if I just take a quick copy and paste of that, I can drop it back into my universal control plane for Docker Enterprise. So go to a new application stack. I'm going to create my stack. Now, here I'm going to show you how we are orchestrator agnostic. First thing I'm going to do is say give it a name. So we're going to call this compose demo. It's going to go on Swarm this time, and paste that in there. Okay. So first thing I've done, taken my application definition, deployed it on Docker Enterprise as a Swarm service. I now should have 3 complete tiers of my application all brought up and working. So quick look at the Compose demonstration, look at services. There we go. We now have 3 successful services brought up on my environment. You can see that there is 1 web tier, 1 database tier, and the 5 API layers. I can even go 1 level further and click on that and find out underneath what the underlying containers are doing. You can see they're all sat down here, and you can do things like have a look at logs and get prompts into them. But once again, I've not had to install anything on my environment. Docker Compose has abstracted everything away. Quick refresh of the firewall, of a web page. Now gets to see a word generator. Every time I refresh the page, new words come in. That's what the API was doing. This was the application. As you can see, it is written for the December conference. I've borrowed someone's application. Okay, but let's say this is going okay, but the application team have read some blog posts. A new Scrum Master's come in and said they want to port this application across to Kubernetes. Fair enough, like no problem. The application is containerized. So we'll go back here to Docker Enterprise. We're going to go back to our stacks. Going to create a stack. Call this one Compose Demo 2. This time, pick Kubernetes rather than Swarm. Specify which namespace, and drop in the same Compose file. That same application definition, I haven't changed anything. It still got the 3 tiers, it's still got the same images, it's still got the same number of replicas, it still has the same firewall port. Create this application. Now I have a new stack, click on it, and you can start to see we're now using different terminology. Instead of using services, we've got this concept of controllers, and we have this concept of pods. Quick look inside of here, you can see that we now have deployments and replica sets. These are our Kubernetes objects, but that same application definition file has understood what I was asking and has translated that into Kubernetes objects. So you can see here that I have 1 database, I have 1 web, I have 5 APIs containers. a quick refresh of the Kubernetes webpage. There we go. There's our application again, running on a slightly different port on the way in, just to avoid a conflict. But the idea here is that I've not had to change anything. I've containerized my application once through Docker. I have defined my application once through Docker Compose, and then I'm able to work agnostic of its environment. Okay, so that's how we can use Compose to abstract the orchestrator. Well, how can we use Compose here to abstract away the operating systems? I'm going to change clusters. I'm going to swap to this one over here. And what's special about this environment is that it's a hybrid environment. If I have a look at the underlying nodes here, you can see that I have a mix of Linux and I have a mix of Windows. I have all of those different container hosts inside of my environment. I even went a little bit crazy and I started putting different versions of Windows in here. So you can see there's some 2019, there's some 2016. Maybe not go that far, it's kind of personal choice. But the idea is we can absolutely support all these various different types. We are not locking you into anything. But what happens if I wanted to deploy an application that had some Linux containers and some Windows containers? For that, I'm going to jump across to the final demonstration number 3. And in here, I have a hybrid application. Now, it's once again, I have services. I have a few different tiers. So I have a database tier at the top. I have a .NET API tier in the middle. And I have a Java web app tier at the bottom. Great. Okay, 3-tiered application. But what's interesting here is that I have some constraints. I say this application is Linux, so start it on a Linux node. The middle one, the .NET API layer, is Windows, so start that on a Windows node. And more in particular, start it on a Windows node of a particular version. We know that I have different Windows environments running here. I want to make sure it starts on the right one. And then finally, on the web server side, start that one on Linux as well. You can see everything else is still defined. So I've still defined my firewall ports, still defined my network, still defined my volumes. All of this is agnostic of the environment. So if the final thing I will do is take this, maybe go a bit wider, take that, and drop it into my hybrid environment. Quick jump on stacks, create a stack, hybrid. This one's going to be Swarm, Kubernetes, Swarm, compose file, and paste it in. Great. So now I've got an application that spans Linux and Windows that's going to use container images that I've pre-built and pushed to a registry. It's going to use overlay networking to abstract away all of the container-to-container communication. So the Linux workloads can talk to the Windows workloads and vice versa. All kind of agnostic of what the environment looks like underneath. Okay, so it's just working its way through now, creating the networks for me and creating the services. Great, done. Quick look at the hybrid environment. Okay, and now we'll start to see that the Linux containers have come up green straight away. The Windows one takes a minute or two, and unfortunately the Windows containers are a little bit larger. But now you can start to see how everything is just agnostic, right? I'm completely abstracted away from what the platform and the operating system looks like, and therefore all applications can be packaged the same way in a Docker container. All applications can be defined the same way in application definition files, and they can all be automated the same way. Today, I've deployed all my applications via the user interface, but this could be done via a pipeline. This can be done via an API scripting job or anything like that. Okay, so give that one a minute or two to come up, and hopefully if I refresh the web page, we may start to get somewhere. Oh, great, it's starting to come up. This one's a simple sign-up application. You put your details into the sign-up page and it stores it in the database. Pretty simple. But yeah, so just to test it all works, quick sign-up. Demo person, couple of days old, and demo at test.com. Cool, so now we're just testing everything works. What I've just done there is I've signed up, I've put data entry in. It should have gone through the Windows API layer, across overlay networking, and then it should store that data in the server, in the database in the back end. To test that it all works, to test that I'm now getting multi-operating system applications, hopefully the data should work in the back end and I should be able to log in. This would be the test. Great, done. Okay, that now starts to show a whole hybrid or hybrid environment inside of our clusters. Okay. One thing, or one of the common questions that come up when we start to talk about Docker Enterprise and we start to talk about deploying Docker Enterprise is how do we deploy, or is there a automated and repeatable way to deploy Docker Enterprise in all of these environments? Being completely platform agnostic is great. However, I don't want to learn, or I need a quicker way to get Docker Enterprise installed on Amazon, on Azure, and on VMware at exactly the same time. I don't want to go away and learn the various different automation tools for each provider. And as part of something we call Docker Certified, or Docker Certified Infrastructure rather, sorry, we've created a whole set of reference architectures, automation tools, and starting to integrate our platform into the ecosystem as part of a wrap around our platform. So with Docker Certified Infrastructure, with DCI, you'll find reference architectures on how to deploy Docker Enterprise in all of those different environments. You'll provide automation tools. The automation tools are Ansible and Terraform based, and it kind of provides a way for you to simply write DCI cluster up, and that will start a brand new cluster on whichever environment you specified. So you could say I want to do a new cluster on Amazon, DCI cluster up, and it will bring up a full new Docker Enterprise environment on the underlying hardware. Then once the Docker Enterprise environment's up, we've just shown how easy it is to move the applications between the different environments and how to define those applications in definition files. Docker Certified Infrastructure has been available now for around about 18 months, and we're going through a few different revisions. And all of this is kind of providing different ways to release, install a Docker Enterprise to our best practices. We're also working closely with the ecosystem. So let's say you wanted to integrate Docker Enterprise with your favorite logging or monitoring tool. We provide an awful lot of choice at that layer too. As we are using native Docker and native Kubernetes APIs, we're not locking you into any particular ecosystem tool. So as part of DCI, we want to stand that up as well. Okay, I just got a couple more slides to finish, and then I will jump through some questions. And I want to spend a little bit of time talking about that reducing data center expenses piece, more or less the business case or the high level content when adopting containers. One of the biggest drivers for people to adopt containers, as well as providing choice on platform, move to the cloud, etc., is to reduce the amount of infrastructure in your environment. Today we run, or traditionally run, one application per virtual machine, When you start to move to containers and Docker, you can now start to run multiple applications per virtual machine. This now starts to provide huge infrastructure savings, kind of reducing the server footprint, reducing the operating system spend, and sort of reducing the patch time. We have over 700 enterprise customers today using Docker Enterprise, and a quick survey from one of them started to put numbers behind that theory. If I started to containerize applications, can the infrastructure savings itself kind of pay for all this new innovation that we're bringing in? And so you can start to see here that if you started with 500 applications, and this was one of the financial services companies on the East Coast of America, when they started to containerize applications, their virtual machine footprint dropped dramatically. You can see here that it kind of dropped from the sort of 5,000 virtual machines down to into the 1,000 of virtual machines. Number of cores have dropped. They actually have started to deploy bigger virtual machines, so the number of cores is quite not relational to the number of virtual machines, but you can see that there's a huge saving there, and the utilization of those boxes goes up dramatically as well. So when you start to adopt Docker Enterprise, when you start to adopt containers, not only are you getting that agility and choice, you're also reducing the infrastructure spend. Whether that's virtual machine count, operating system license cost, patching cost, or driving up server utilization. This is all part of the wider Docker Enterprise platform. Today, we had a look at Desktop Enterprise to containerize our applications locally. We had a look at Universal Control Plane as a way to deploy those applications in Amazon and in Azure. And we used the Docker Trusted Registry as a centralized point to push the container image from the developer to an artifact store and then to the operators clusters. We're working hard at making sure that there is a consistent look and feel across this workflow and helping developers or application teams move applications quicker from developing them locally through to running in production, agnostic of any environment. This platform is starting to get industry recognized. With the first Forrester wave came out in Q4 for container platforms, and we came out as a strong market leader in this space. That idea of taking the applications straight from the developer through the artifact store and out to production clusters is a key unique of the Docker Enterprise proposition.